Climate change is a natural phenomenon. It's always been, but it always will be.
Climate does change. It always has, and it always will.
Yes, okay, the climate changes. In science, that's what's called an observation, just as we can observe lightning, shooting stars and earthquakes. They're all natural. But the role of scientists isn't to sit back and marvel at all these natural mysteries. It's to find out why they happen. So what climatologists want to know is, what causes the climate to change? And after 2 centuries of research, they now have a pretty good idea. Let's just recap. Insolation is the amount of energy we get from the sun. It depends not only on the energy output of the sun, but on how the Earth is positioned to receive it, its tilt and orbit. Greenhouse gases, things like water vapour, carbon dioxide and methane. And thirdly, particulates and aerosols. They come from volcanoes and meteorite impacts. They block sunlight and cool the Earth down, and aerosols caused by industrial pollution do the same thing. Finally, the Earth itself can amplify these changes through positive feedback, and even the configuration of the continents. And so we come to our first urban myth, which happened to pop up in the comments forum of one of my climate videos. The myth is that since temperatures were higher in the past with lower CO2, and sometimes lower with higher CO2, carbon dioxide can't be a factor in climate change. Even Bob Carter has fallen for this one. Here's a graph he produced, apparently showing no correlation between carbon dioxide and global temperatures over the Phanerozoic, the last 500 million years of the Earth's history. But I'm pretty sure on this one, Bob, because it's in all the scientific literature. You wouldn't expect to get a match-up because carbon dioxide isn't the only factor that affects global temperatures. No climatologist ever said it was. Just read the journals. On a geological timescale, the sun is the other main driver of climate, and as every geologist should know, solar output was much weaker in the deep past. The red line here shows solar output throughout the Earth's history. What we're interested in is the last 500 million years. Like most stars, the sun has been growing increasingly brighter with time. If I compared solar irradiance with global temperatures over the last 500 million years, I'd get no better a correlation than Carter did with carbon dioxide. But if we combine the two, solar irradiation and carbon dioxide, then there's a very good correlation. I'll come back to this later, but why is the correlation so good if there are all these other factors? Well, the Earth's tilt and orbit are predictable and run in cycles. The effect of particulates is usually short-lived, and the concentration of water vapour is controlled by temperature, so it acts as an amplifier rather than a prime driver of climate. Over the long term, carbon dioxide and solar output, or irradiance, are the biggest variables. Let me put this very simply with an analogy. Let's say you're staying in a house in midwinter, and all you have to heat it with is a fireplace and an electric heater. If they're both full on, you'll bake, and if they're both turned down very low, you'll freeze. The house could even get cold if the fire's going nicely, but the heater's turned down very low. So the Earth's climate depends on a combination of factors. And it's actually quite lucky for us that carbon dioxide levels time to balance the growing irradiance of the sun. 2 researchers who are skeptical of the influence of CO2 have put forward an alternative idea, that the Earth cools as it passes through the spiral arms of our galaxy. The idea is that cosmic rays ionize the air, and that seeds clouds, and clouds reflect sunlight, and that cools the Earth down. Shaviv and Vaza's paper has been widely circulated, but not widely accepted within the scientific community. No, not because of some conspiracy of evil scientists, but because the idea that cosmic rays seed clouds, and that clouds cool the climate, hasn't been shown. I explained the background to this in my video Climate Change: The Objections. Also, geologists say there are problems with the dating method used, and with the correlation itself. And as the authors themselves admit, the hypothesis can't explain current climate change because it takes millions of years for the solar system to pass through a spiral arm. I'm very glad a couple of qualified skeptics who know their subject chose to publish their research in a respected peer-reviewed journal. That's how scientific procedure is supposed to work. Unfortunately, Shaviv's university issued a press release at the same time the paper was published, making claims that weren't in there. Most journalists read the press release and didn't bother to read the paper. So the headline that went around the world was this one, even though the paper says nothing of the sort. In fact, it specifically argues against drawing inferences about current climate change. Shaviv and Vesa go on to say that other research suggests cosmic rays may also work on a smaller timescale, but that hypothesis has since collapsed because of a mathematical error, which I explained in my video, Climate Change, The Objections. So what we're left with are two very clear drivers of climate that fit very well with a reconstruction of the Earth's climatic history. From 2004 to 2006, researchers reviewed the scientific literature and examined solar output, carbon dioxide levels and temperature data from every period of the Phanerozoic, from the Tertiary to the Lower Ordovician, and they found a very good correlation. Critics say the correlation breaks down in two places, the Ordovician and the Cretaceous periods, when there were very high CO2 levels coinciding with extensive ice cover. But of course we have to remember the climate isn't driven by carbon dioxide alone, and at times even the combined influence of solar output and CO2 levels can be upset by the other factors that affect climate. The Ordovician seems to be a particular favourite with amateur skeptics because it experienced a full-blown ice age. I'm often referred to this website, run not by a climatologist, no surprise, but by a mining engineer called Monty Heeb. To the consternation of global warming proponents, the late Ordovician period was also an ice age, while at the same time CO2 concentrations then were nearly 12 times higher than today. According to greenhouse theory, Earth should have been exceedingly hot, blah blah blah. No, according to greenhouse theory, if you want to call it that, global temperatures vary depending on several factors, not just carbon dioxide. So let's go back over 20 years of research into the Ordovician climate and see what real climate scientists have discovered. First of all, solar output during the Ordovician was, of course, much weaker than today, about 4.5% weaker. That should have been enough to plunge the Earth into an ice age. It certainly would today. But in fact, the climate was much hotter, way beyond any forecast of what we're expecting in the next 100 years. How can that be? Well, paleoclimatologists have concluded it's because carbon dioxide levels were around 18 times higher than today. So if all that carbon dioxide was keeping the Earth hot, why did it suddenly descend into an ice age? This was a problem facing geologists over a decade ago. The only way to cool the Earth down would have been to remove billions of tons of carbon dioxide from the atmosphere. But there was no known mechanism for that happening over such a short period of time. In 1994, carbon dioxide levels did indeed drop dramatically towards the end of the Ordovician. The reason still wasn't clear. Climatologists calculated that such a drop would have caused global temperatures to fall, but there was still more than enough CO2 in the atmosphere to prevent an ice age. Then in 1995, researchers from Texas A&M showed that one other factor had come into play, the position of the continents, which had joined into a supercontinent near the South Pole. They also concluded that the Earth's orbit might have played a role in reducing solar irradiance even further. 2 years later, researchers from Pennsylvania State University calculated that all these factors put together, including the drop in carbon dioxide levels, would have been enough to precipitate an ice age. Then in 1999 and 2005, two papers began to shed light on the reason carbon dioxide levels fell. During the Ordovician, the Atlantic oceanic crust was subducting under the North American continent. This thrust up the Appalachian Mountains. As they rose, the silicate rocks in these newly formed mountains rapidly weathered. This happens through a simple chemical process. Carbon dioxide reacts with silicate rock, forming calcium or magnesium carbonate. This is washed away into the sea, gets taken up by organisms in their shells, and then gets buried as sediment that turns into limestone or chalk. So the carbon that was once in the atmosphere got buried at sea, and over millions of years, trillions of tons of carbon were removed from the air. So scientists are more than happy to talk about this U-boat 21. In fact, they've been yakking about it for well over 2 decades. It's just that you haven't noticed, because it's all been published in scientific journals. These aren't inaccessible. You can find them quite easily online. But they don't get passed around and repasted on internet blogs. They require a bit of effort. I suppose it's quicker and easier to read a blog by a mining engineer and come away thinking you're an instant expert. It's kind of the fast food approach to science. So all the experts who argue that the Earth was cold when carbon dioxide levels were high miss the equally irrelevant point that the Earth was much hotter than today when solar output was much lower than today. It's a combination of factors that drives our climate. But a lot of people continue to think that the sun is acting alone.
None of the major climate changes in the last 1,000 years can be explained by CO2.
Well, I can beat that. None of the major climate changes in the last 1,150 years can be explained by CO2. And there's a very good reason for that. CO2 levels have been more or less constant during that time. As we saw with the example of the house in winter, if one fire is constant, then the temperature rises and falls according to the output of the other. A study that looked at global temperatures over the last 1,150 years found exactly that. With carbon dioxide levels steady, the sun was the main driver of climate. But for the last 30 years, the output of the sun has been more or less constant. So as climatologists predicted, temperatures have risen concurrently with a rise in the other historical driver of climate, carbon dioxide. And to the other MOOC experts that make the obvious and rather puerile observation that the climate always changes, well, now you know why.